Okay, Steve, so you mentioned in one of the panels that you think it doesn't make any sense to use air, which is an insulator, as a heat transfer medium. So can you elaborate on that?
Yes, absolutely. So we've focused on liquid cooling in our new data center. As a heat exchange medium, liquids are about 3 orders of magnitude more efficient than air. So you can think of a juice glass of water having the same cooling capacity as a whole room full of air. And then there's transport efficiency. So the pump energy needed to move that juice glass of water is much less than the fan energy needed to move a room full of air. And as we look at advances in computing technology, the systems are going to higher power densities. So in a single rack, you're going to have much more energy, which goes to heat, which is going to have to be dissipated. And so if you take advantage of the thermodynamics, you have to use liquids to be able to get the heat out of that sort of center of the rack as efficiently as possible. And then you can keep your chips in a thermally stable environment. You can capture the waste heat directly, so you need component level liquid cooling. And then so you get a very warm return because 40C water has many more uses than 40C air.
So tell me the solution that you've chosen for your high performance computing data center in Colorado. You're actually recovering heat to the building and eventually maybe to the campus. So in order to do this and in order to take this decision, what kind of factors did you consider?
So we took a holistic, we called it a chips to bricks approach for the data center. So we focused on what the sort of thermal safe limits were on the chips. We integrated the computer racks into the data center and the data center into the building, so it was a holistic view. So we're, as you mentioned, we are capturing waste heat off of our systems right now at 40C. The building, our data center sits within an integrated research facility, and the data center is the primary heat source for the building. In the wintertime, we use it for snow melt, so we've got snow and ice-free plaza areas and walkways outside the building. Even in the summertime, we have laboratories that are environmentally controlled, so we will run air across a chiller to reduce the humidity, and then that air has to be reheated again. So even in the summertime, we're capturing about 20% of the waste heat out of our data center and using it. So it's not certainly there's more opportunities in the wintertime for waste heat reuse, but even in the summertime, in the early mornings, we have large temperature swings and we're able to use that waste heat. But it required an integrated approach to look at the whole system, not optimizing the computer or the data center or the building in isolation.
So you have definitely moved to a very green data center. Is the general trend in the US for the ICT industry to move to sustainable solution fast enough, or is it too slow?
For my purposes, it's too slow, but the fact that it's moving at all is very encouraging. And I think as the technologies improve, both in terms of efficiencies and cost drivers in renewables and approaches, the IT industry tends to be a risk-averse enterprise, so the change is slow. But I think the change is coming, and once it starts moving, it will snowball.
So, Steve, tell us what factors would make the transition of the US ICT industry into sustainable energy solution fast enough?
I think the cost drivers have to be in place. It's got to be. I mean, we pursued energy efficiency because it's part of the mission of the laboratory. So the green we care about is sort of the efficiency, but the green businesses care about is the bottom line. And there's got to be a cost return on investment and a business case that can make. Otherwise, the businesses won't do that.
So what about the non-sustainable energy in the US? Isn't it too cheap to make it a good business case to go green?
It's not too cheap. But it makes it a slightly higher hurdle than in places that don't have cheap coal or natural gas. So the advances in renewables, both in terms of solar and wind, the prices are coming down, and We're seeing coal plants being turned off because of less expensive renewables and natural gas, which has a lower carbon footprint.
What about heat recovery? Is that limited due to the lack of infrastructure? I know that you have a campus pipeline system that's rather unique. So is it the lack of infrastructure on the heat recovery side that makes that sort of limited in the US?
So it's twofold, right? There's a lack of infrastructure to take advantage of it. Buildings come online, sort of large capital investments. Those are slow to come in place, but also sort of the southern half of at least in the U.S., the need for waste heat recovery is not as predominant as in the northern parts of the U.S. A lot of data centers in Texas and in Arizona and Georgia. They say we need cooling. So if we have ways perhaps to convert that heating through absorption chillers or something, we have to find site-specific opportunities. The fundamentals hold. You have to be efficient in what you do, reduce the amount of energy you need, and then find opportunities that are site-specific for reusing that energy that is produced.
What about Colorado? There are some quite significant mega data centers being established both in the Denver area and further south in Colorado, where there should be some need for heating.
There is some need for heating, but they tend to be put in isolated locations, and you have to have a certain density of your operations. Otherwise, it's a stranded resource.